Welcome back. We're ready to actually start writing code. I know, it's exciting. And we're going to do this actually in a way that's different than you've seen yet altogether at all. Because in the other class, right, in the intermediate class, this would have been a point where Nate would have already created a block controller and actually created these controls off of a block controller and drug them on. We, however, are not going to do that approach. What we are going to do is we are going to click on that other tab right there called UCI script, which I haven't shown you until now. And notice what happens. Here is our text editor window. I'm going to click on that tab, and it's going to break free, and I'm going to split my screen left and right a little bit so that we can have a vision of both the UCI and a vision of the editor window. And let's come to line 1. And for many of us, this is where the paralysis begins, because it's, okay, cool, I have a cursor, it is blinking, and in fact, I think it's laughing at me now, saying, what are you gonna do, big guy? Come on, huh? What is it? And so I want to create a category of an approach for you in your mind. Before you try to write any syntax at all, I want you to adopt this practice. Just write it out in comments. What is it that you want this thing to do? Well, we're going to start by making a comment in Lua. And we're going to start by typing --. You notice that it comes in as green. And we're going to think to ourselves, when button is pressed, what do we want to have happen? When I press the button, I want a couple of things to happen. One of the things that I want to have happen is I want to set the layers appropriately. All right? So that means sometimes, right, if I poke button number 1, I want layer number 1 to turn on and layers 2 and 3 to turn off. What else do I want to have happen when I press the button? Well, we want the buttons to also interlock.
Yeah, they got to turn off too.
They do, right? So we also want to set the button feedback appropriately. So there's that. And then this is also a thing that I want us to adopt as a practice. We should also send some debug info to our window. Because that will help us know if what we're doing is doing the right thing or not. And so for us, this is what we want to do when we poke a button. Fantastic. Which then brings us to line 5. Now it's laughing at us again, Nate. The blinking cursor is laughing at us because we don't know any syntax. We've made a plan, but we don't know any syntax. So we actually need to take a moment to talk about some Lua syntax. We're going to take a quick tour of an introduction to Lua. A primary source for learning Lua is right here in the actual manual to Lua called Programming in Lua 4th edition by Roberto Uroslimsky. That's the guy that invented Lua altogether. One of the most important things to realize is that Q-SYS is using Lua as our scripting language, as an extension language, which is natural for Lua. Lua is also very popular and for other applications out on the interwebs. In fact, if you were to ever Google how to do thing in Lua, you might actually wind up on one of these kids forums for Roblox. Turns out, as it was in our day, that the 12-year-olds actually are pretty good with the technology and they know some things. Now, one of the things, Nate, that they're not going to know about is they're not going to know about all of the extensions to Lua that Q-SYS has given into the developmental environment. We're going to talk through a lot of those gifts throughout this thing. But one of the best things that you should know now is that when you're writing code and you need a little bit of help, highlight it, hit F1, and guess what? Your browser is going to pop open if you're connected to the internet, and it's going to go to the help file, which is live online, being updated with all of the new information for different things. In Lua, there are a number of reserved words. This is a partial list. of the reserved words that you need to know about. And, break, do, else.
What do you mean by a reserved word in general?
A reserved word means that, that in this particular computer language, it is a word that means something and has a specific purpose and use within that environment. Well, one of the implications is that you can't use that word for your own devices. It already exists and you can't override it. You can't make it be something else. And is always going to be and, where it literally means this thing and this thing taken together. So reserved word just simply means that it's already dedicated for specific purposes inside of the programming environment. You can't redefine it to be something else. These are the ones, there are a few more, but these are the ones that you'll probably run across as you do some things. And the next slide here is actually a really important idea. Computer languages have data types. Data comes in different types. That's not helpful, Jeff. You got cats, you got dogs, you got alligators, you got crocodiles, right? These are all different kinds of animals. In the same way, we have different kinds of data being saved. And so we actually have a function in Lua that is useful. It tells us what kind of data type a certain something is. It's called the type function. And so if we do type of nil, it tells us that it is a nil data type. Nil is a proper data type in Lua, and it effectively means delete me. Send me to the garbage collector. I'm not needed anymore. That's effectively what nil means. Okay, type of true is a Boolean. Now, this is a tricky one. The type of 10.4 times 3 is, it's not a float. You might be thinking, that's a float. In Lua, Lua doesn't say that it's a float. Lua thinks about things the same way that my mama thinks about things. My mother is, her name is Mima, and she is 80 years old. She's properly old. Nate, properly old.
So she's actually old. She was there before the world was born.
Actually old. And so she thinks about numbers the same way that Lua thinks about numbers, which is like, if you tell her what is 10.4 times 3, she's going to say, well, baby, that's a number. And she's right. It is. It's a number. Now, for those of you with computer science experience, you're like, bro, that's a float.
For people without computer science experience, what is a float?
Yeah.
Because I'm thinking an ice cream float, and I'm pretty sure it's not that.
Yeah. So I'll tell you the other one, right? So the other is integer. So typically in computer science, when we think about numbers, we have whole numbers, which we call integers, and then we have numbers with decimal points in them, which we call floats. And that's really all it is at the end of the day. So from Lua's perspective, there is no float, there is no integer, there is only number. So that's a thing. Lua thinks the same way that Mima thinks about things sometimes. Okay, type of quote hello world is a string. We'll talk more about strings for sure as we move forward. Type of io.time is user data. Type of print is a function. Type of type, also function. Type of curly bracket. This is actually really important, and we will definitely spend more time on this. It's a table, Nate. That's how you construct a table. Okay, and then lastly, let's give Nate a little pop quiz. Type of X is a string. Why is it a string, Nate?
Because the answer to a function that is telling you what a type is it's giving you a word, right? It's giving you a word, and you're analyzing what is that word. Well, the word is a string of characters. It's text. It's a string.
He got there. I give him credit. For some of you, if you know anything about Lua, is that it's dynamically typed. What we mean is that you can just call variables into existence, and they are whatever data type you assign to them. So in one line, you can say that my variable is set to be a string, and that makes it a string. And in the next line, if you assign it a number, that makes it a number. It's not a fixed declaration and assignment of data type. Here's what I mean, Nate. Lua is meant to be fast and nimble. And in other languages, you would have to like declare what a variable was going to be, and it was what it was. It was always that thing. It never changed. It's not how Lua works. Lua is, my favorite little expression here is pew, 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 pew. It's finger guns when it comes to syntax sometimes. Its job, its goal, its reason for living is it tries to remove as much syntactical friction as it can while still holding together and being cohesive. Let's keep her moving. Since we're talking about strings, let's just take this much more to nail a few things out about them. In Lua, strings are 8-bit clean. All that really means is that Lua takes 8 bits by 8 bits by 8 bits for its string of characters. You want to encode in UTF-8, you want to encode in ASCII, it's going to work out just fine. Additionally, Lua, you can delimit strings very flexibly. In Lua, you can use double quotes. You can use single quotes. Lua really doesn't care.
Now, when you're saying delimiter, you're really just saying the character that indicates it's the beginning of a string of text and the thing that tells you you're done with the string of text.
Exactly.
And anything inside of that can be whatever you want. So when you're talking about reserved words, like you can still use the word and or while or function or whatever inside of a string of text because that's already noted that it is not part of your code. It's being noted this is a string that you're using for something else.
The only thing Lua cares about is that if you start with double quotes, you end in double quotes. If you start in single quotes, you end in single quotes. But you can literally go back and forth from one line of code to the next line of code. Lua does not mind at all. One more thing before we write code, and I know, sorry, we needed an information injection here. Let's take a look at an actual chunk of Lua code. We are opening our chunk of code by making a declaration that we want our variable t to be a local variable. Lua is kind of interesting in that every variable is global unless you specifically call it local. So in this case, we are defining a local variable. Its name is t, and the single equals says set it to be the number 1. And then we get into a bit of flow control. We have if that variable t is greater than the number 3, then print the string above average. Else if t double equals 3, that's a double equals, Nate, is actually the official word here, is the logical comparator which assesses equality.
That's a lot of description.
It is a lot of words, which is why I say, does t really equal 3? Is how I actually say it in my head. I don't usually call it the logical operator which assesses equality because it is so many words.
I always say equivalent. I say, is t equivalent to 3?
Well, that's because he's from California and I'm from Georgia. Does t really equal 3? If yes, if no. Yeah, so if t actually equals 3, then print the string average, else print the string below average, end. So that's actually an important use of the keyword, end. We are concluding the chunk of code. This way, Lua knows where to start and where to finish with this bit of logic. When you start writing logic, you're opening it, and so when you conclude a particular chunk, you have to end it. So let's talk through this. What's going to get printed out, Nate?
It will be dependent on what t is.
T is equal to 1.
Oh, well then that is less, it's not more than 3 and it's not equivalent to 3, so it's else. So it's going to print the word below average.
Yeah, it's going to print below average. So that's actually one of the first things to realize is like, how do we organize our code? You put your most specific cases first, your most general cases last. and that's how it's going to evaluate. The other thing that you should know, and again, this should probably be very intuitive to you, is that as soon as Lua finds one of the first winning condition, it executes and then it's done. It doesn't keep going down the list. The other thing that some of you are probably saying is, hey, Jeff, where are the semicolons? And the answer is they're completely optional. Lots of other languages use semicolons to delimit the end of a line of code, but Lua doesn't care. The other thing that you might be saying to yourself is, what about the way that all of those prints are indented? That is really important in a language like JavaScript. Actually, Nate, guess what?
It's really important here too?
Lua doesn't care.
Lua doesn't care.
Lua doesn't care.
Lua's a honey badger.
I guess so.
Yeah.
Lua is the honey badger. Lua don't care.
Now, all of this stuff, right? If you can't quite read it yet, if this was a little bit terrifying, maybe go back to the intermediate course, right? All this idea about flow control, about creating variables, we're going to cover it. Jeff's going to go through making variables and what ifs and else's are. But if this was like, holy Nelly, this is too much, this might be a good red flag for you that you want to go back to the intermediate course. Well, we'll talk about that kind of logic construction. If this was comfortable enough, then you're probably in a good place.
Yeah, and I have to tell you, we're gonna pick up steam. I know it might feel a little slow, but that's because we're starting up here on the beach, and we are progressively going to be walking our way out into deeper and deeper and deeper water, and you're going to be very comfortable, I promise you. So, since we have had that little brain dump of introduction to Lua, it's time for us to turn the corner, come back over into Designer, and we're ready to pick up where we left off. Remember, we put in what was our game plan. It's now time for us to start executing our game plan. And as it turns out, it's also a really good time for a break. So let's put a pin in it, and I'll see you again in just a moment.